Hello, everyone. Thank you again for joining us at the 2023 Sloan Sports Analytics Conference Competitive Advantage Talks presented by Kager, also known as Craft Analytics Group. My name is Evan Lefkowitz. I'm a first-year MBA student at MIT Sloan, and it is my pleasure to introduce our panel, Sports Analytics with Natural Language Processing. Please welcome our speaker, Ben Hendricks, Staff Software Engineer at LinkedIn.
Thank you. Hi, everyone. Just grab the clicker. Thanks, Evan. Thanks, everyone, for having me, first of all. So like Evan said, my day job is as a staff software engineer at LinkedIn. But on the side, I run this consultancy that I call Hendricks Software. And I'm going to really be talking to you today about my master's thesis I finished last year, which was Sports Analytics with Natural Language Processing using crowd sentiment to help pick winners in fantasy football. Quite the mouthful. A couple other things to kind of talk about at the very start here is I'll be talking about both research from my thesis and the subsequent kind of findings I had in the past season, which was going to be, I think, interesting. A couple terms I want to set up first and foremost before we get into it. Projection. I mean, this term you probably kind of have an idea about, but the thing I want to be really specific about here is it's both a numerical estimate, it's a number, and it's specific to a set of scoring rules, right? And so what I mean by that is, on DraftKings, you might have PPR, or you might have some other set of rules to score, and so the projection is going to differ based on that set of scoring rules, right? So the reason I'm saying this is all of the research that you're seeing today was using the DraftKings set of rules. That's just an arbitrary choice. That's just what I tend to use, but you could easily, all of this stuff is very easily applicable to any set of scoring rules, and it's easy to change as well. And the other term I'm actually going to start with a story about. So quick, interesting story. In 1906, the scientists went to a livestock fair and was really surprised to see this kind of thing that they were doing where they were asking all the people there to guess the weight of an ox they were about to slaughter and butcher. And they had a bunch of experts there also predicting what the weight of the slaughtered ox would be. And what was really interesting is out of 800 people or so that answered, the average of all of their guesses was only 1 pound off the actual weight. And so this kind of led to this idea that through aggregating somewhat random predictions, right, from non-experts, you can actually get a very accurate prediction. And I mean, that prediction was closer than all of the experts predicted in that scenario. And so how does this apply to fantasy football? And you saw crowd sentiment in the title. What does that mean? In my research, what I kind of called as the crowd is essentially Twitter, right? What's happening on Twitter, tweets about players, is kind of the crowd that I use. And I'll talk about other crowds that I can use as well, but that's really what I use here. And so the wisdom here is trying to extract information from those tweets. And the way I did that is basically running sentiment analysis on those tweets, and I'll talk more about that in detail. But first, why do projections matter, right? I mean, first of all, fantasy football is a really huge market. I'm actually curious, quick show of hands, who played in a fantasy football league in the past year? A lot of people, yeah. Who played in daily fantasy? A few less. What about sports betting just generally, any kind of sports betting? Yeah, so there's a lot of different uses for projections, right? All three of those use cases, I think you would probably find value, right, in projections about players. And the key thing too is, I mean, I actually tried to find this for this presentation, but I couldn't find the wording anymore. But on DraftKings, they used to have information about how there's sharks in the water, so to speak. People who have these very advanced models and that usually win a vast majority of the games, right? I forget the exact numbers, but it was something like, they win 80% of profits that are going on in these games. And so, these projections and advanced projections are the shark advantage for these players. And then the last thing is it's useful in other contexts, right? And so I could imagine, I think an earlier presentation was talking about how they kind of plan for their team and the team personnel and all that kind of good stuff, right? Like a team itself in the front office is going to want to know how to project and accurately project their players' performance. And these tools, I think, could be used there as well. But that was not what I did, but could be used there. So to talk a little bit about the data sources that I used in my research, it was mainly these 5. There's a couple more that I'll talk about, but the big one is Twitter, like I was talking about, right, and getting tweets. DraftKings, again, is the platform I mainly used, and in my research, it was primarily kind of doing daily fantasy, and so I was using DraftKings as the set of players for a given week, right? NFL.com always has projections for all players every week, so that was another data source I used. Fantasy data is, they have an API that you can use to kind of pay for more of this kind of data. And then this, in the top right, you see this kind of it's actually a screenshot of a GitHub repository. Someone had put together, this kind of clean data set about weather during NFL games, but it was only up to the 2020 season. So as I talk about, the 2022 season that I mentioned, I'll talk about, that wasn't there. And so the system architecture that I'm kind of talking about, right, like I said, I start with kind of an input from DraftKings that gives me the set of players that I can then go and fetch all the data about all those players. That all kind of goes into a database. The Twitter data goes through an extra step of sentiment analysis, and then the modeling happens, right? And I'll talk about the different kinds of modeling that I did and kind of the pros and cons I saw there. And so I'm going to start, like I said, with the sentiment piece, right? So focusing in on that kind of Twitter to IBM Cloud box. So lots of people tweet expectations about players. And so that was really like the core idea, right? How can I leverage that information that's already out there? And so the method is really simple, right? You fetch tweets, you process them in terms of, kind of more standard natural language processing, pre-processing steps. So things like removing emojis, removing punctuation, removing stop words being like the or right? Like these simple words that don't really add value. I think I had like 9 or 10 pre-processing steps. And then I send that kind of blob now at this point, right? It's kind of really processed text to IBM Cloud, which has an API that, given a blob of text, can return sentiment about that text. What's really cool actually is their API also does entity extraction for you. And so it will both give you a sentiment score for all the text you gave it and for any extracted entities. And what was awesome to see in my research is that every single time I would ask basically for sentiment about a blob of text that was specific to a specific player, it was always extracted correctly. And so basically I have 2 different sentiment features per player, one that I call document sentiment and one that I call player sentiment. And so document, you can see that kind of blob of gobbledygook that's kind of in red. That's what the text looks like when it's sent to IBM Cloud. And then what you can see in the top right is a sense of the scale of number of tweets per player, right? There were a lot of tweets, right? So on average, we're talking about 5,000 tweets per player per week, right, in the 2020 season. The crazy thing, though, is the max is so much higher than the average, right, which just shows this kind of expected, I think, thing where top players just get tweeted about more, right, and some of the lower players really don't have as much data. But that's fine in fantasy football for a second because the top players are the ones scoring most of the points anyway, right? So that's the ones that you care about most anyway. And so let's talk about all of the data. So essentially there were a bunch of features that I tried and went through in my research. Here you see the 26 that kind of ended up in my thesis. And you can probably see a kind of big mix of kind of engineered versus non-engineered features. One of the key things in the engineered features that was interesting is that when looking at previous, or when trying to use current season previous data as like a feature, using the last 4 weeks I found was ideal and gave the best results. So what I mean by that is, starting in week 5, you can use weeks 1 through 4 as your training data, right, for that week 5 projection, right? And then week 6, you theoretically could use 5 weeks, right, and so on and so forth. So like, originally I thought, okay, well, by week 17, I'll have 16 weeks of data, so the projection is going to keep getting better and better, right, because the more data, typically, the better, right? But what's interesting is that wasn't the case. Actually, just using the past 4 weeks was the ideal use of the previous kind of weeks of raw points, right? So here by average points, it's literally the number of fantasy points they scored in the past 4 weeks averaged. And so like I mentioned, right, there's 2 sentiment features, player sentiment and document sentiment. Player sentiment, the extracted feature from IBM Cloud, was by far the best sentiment-based feature. And then I had a bunch of other kind of weather features that you can see. Is extreme weather. I thought that was an interesting idea to think about, okay, well, if just the temperature or the wind alone as a feature doesn't provide any value, can I create some kind of computed metric that says, okay, well, if the temperature is really low and the wind is really high and it's blizzarding, okay, that's extreme weather, maybe that's going to have an impact. Turns out it's not that useful of a feature, at least in the way I did it. And so now I'm going to get to the more of the results and the kind of interesting bit, I think, in terms of the modeling and the results. So in 2020, the thesis research showed that I was able to get 29% more accurate projections than NFL.com with a regression model. And you can see the specific features that I used in that model. It was only 11 of those 26. I tried a number of neural networks. I mean, I tried a LSTM, which is kind of a time series-based neural network. It did not train well, and that's because there's not enough data. and you know, one thing I should have mentioned earlier, right? Like the NFL is a very interesting projection space because there's so little data, right? You're talking about 17, 18 games per season per player, and you know, you compare that to like the NBA or MLB, right? Like they have 5 to 10 times more games. That number of games just gives you more data, more to train on. You can get more accurate projections, and so yeah, time series neural network did not work well. Kind of a more basic neural network got it to work. I mean, the time series neural network didn't even get it to work correctly. But a regular neural network in the 2020 season, I was not able to get better performance than NFL.com projections. That's very different than the past season, though. So in 2022, the regression model, which has a slightly different set of features, because I added some feature in the meantime, only had a 12% improvement over the NFL.com projections, which is not bad, but the neural network that I built for the 2022 season had a 17% improvement. What's really interesting, though, is that 17% improvement is with no sentiment features. In 2020, there were sentiment features that added value. 2022, there were not. And so that's what I really want to talk about now, as why. Like, why did this happen? And I think there's really 3 kind of core reasons that are coming to my mind as to why this could have happened, right? First of all, in 2020, when I was doing my thesis research, I was basically retroactively fetching tweets, right? Like this is in 2021, the season had already ended, and so I was able to, fetch much more tweets, but that's not the point I'm getting at right now. There could have been issues where I actually fetched data from during or after a game, right? And that would encode the result in those tweets. And so that's not gonna be that's gonna be very valuable. And so what that means is it's possible, right, that 2020 result was influenced by that, right? From what I checked, it didn't seem like it, but it's possible, it's theoretically possible, right? In 2022, that wasn't, because I was doing it live, so to speak, where I was fetching the tweets before the games had even happened, and so that was not even a factor that was possible. Obviously, a lot of things have happened with Twitter over the past couple of years, and so as an ecosystem, a social media ecosystem, I work at LinkedIn, I understand how these ecosystems evolve over time. That's my day job. Twitter dynamics could have changed, right? More people could have been on it. More people could there's so many different things. One key thing is 2020 was the COVID season, right? As you can see in that picture, right? That's the Superdome with a game going on and there's no fans, right? Well, what were those fans doing? I have a theory. Maybe they were at home tweeting, right? Maybe there was more kind of Twitter activity about some of these events because they were at home and couldn't go do these kind of conversations in person. And the last thing is in terms of the retrieval window. So like I was saying, right? I was able, for my thesis, to retroactively get data, and I did so by getting basically 24 hours before any game, all the tweets about a player in that 24-hour window. That ended up taking a lot of time. The Twitter API, I'll talk about in a second as well, is not very fast. And so, and the academic access that I had is limited to 10 million tweets per month. So it took me actually 3 months to get all the data for the 2020 season, just constantly having it run essentially until I hit the rate limits. To fetch the data for 1 week, right, to kind of compare against the 2022 season, it had taken many hours, if not more than a day. So I shrunk it, right? For the 2022 season, I only retrieved 3 hours of tweets per player per week. This meant that the results could come in much faster. Actually, also, to the point I made earlier, right, that you only really care about the top players, I stopped fetching tweets about all players, and I started only fetching the top 250 by fantasy points the week before. And so that's what led me to be able to generate projections on a weekly basis, kind of in this live format, relatively quickly. I think I still, even for 250 players and getting 3 hours of tweets, was still on the order of 30 minutes to an hour of fetching data, which is a little too slow in my opinion. Especially if the end goal is to be able to run all of this within the 90-minute window before a game, such that you have the latest injury reports from the league. So like I mentioned, Twitter API, kind of annoying. Very harsh rate limits. Not only is that 10 million tweet per month cap that I talked about, but there's a bunch of other rate limits. And the funny thing is, it doesn't even really work that well at those rate limits. Like, you basically have to rate limit it even more aggressively for your error rates to not be super high. So at first, when I just let the Twitter error limits, just kind of take effect, I had error rates in the like 50% plus. So what I mean by that is I would make a request for tweets, and it would just fail. And so you have to retry, right? And by just lowering the rate limit, or by basically rate limiting myself more aggressively than Twitter was going to rate limit me, I was able to get the error rate down to like 10 or less %, which, even though the rate limit was slower, so I was making requests slower, was overall faster for me because I had fewer failed requests that then required such manual effort to go back and do. Because as you can imagine, I'm not doing one request per player, right? I'm running a script that is getting all of the players' data, and it's only at the end that I'm like, okay, well, 50% of the players' data is not here, so I have to run it again. And then lastly, well, not lastly, but there's no ability to parallelize with the Twitter API with academic access. I mean, maybe there's a way that I could have gotten more academic access, but it was already hard enough to get the one seat I had. And if I had wanted to parallelize, I'd have to pay, because I'd have multiple paid accounts to kind of make API requests, and the cost is really high with the Twitter API. I don't know if it's even going to stay around that much longer, but last I checked, it was on the order of like $1,000 a month for something like 100 to 500 requests. That is very, very expensive in the world of kind of API costs. That said, I'm not only going to speak negatively about the Twitter API. It is very good. It has very, very good query capabilities. And that's one thing, actually, I really feel like I could have used more of, and I'll talk about that in a second. And so, yeah, so what's kind of next for me in this research, and where I want to go with it? One key thing that I kind of mentioned at the beginning is I've so far only used Twitter as the crowd source. And I want to ingest other news content and also apply sentiment to that. Some of it will be crowd, some of it will actually be from kind of experts, right? So like ESPN, Yahoo Fantasy, those articles, right? That's more from experts, but the sentiment from that could be a useful feature here. And then also, in terms of within the crowd, maybe there's other sources like Discord or Facebook groups or something else that I could use, right, as a data source here, and might be free. Another thing is, one of the key assumptions in my thesis was that the injury information about a player would be encoded in the tweets about them, right? And so, I mean, it felt like a fair hypothesis, right? If someone's hurt, all the tweets about that player are going to be like, he's hurt, he's not going to play today. But the reality is, it wasn't as clean as I'd like it, and injury is such an important factor in NFL games and projections that I want to add a very explicit injury feature to the data set that I'm talking about. And then, yeah, like I was just talking about, right? Like, there's more I could be doing with Twitter in terms of the query capabilities. So what I mean by that is I'm literally just using the player name and searching for that, and that's it. Get whatever tweets come back. But the capabilities of the API are way, way beyond that. I mean, they have like a 1,000-character limit for the query, meaning, I mean, you can add, and they have a bunch of different kind of, it's almost its own little programming language within the query set space that you can kind of ask for very complex things. And so that's where, maybe there's more that can be done there to like really fine-tune and remove more of the spam. Because one thing I didn't show in the data, but there were a lot of repeated tweets in the data sets I was fetching. And so what's the point in fetching? Spending all this time and energy fetching all the tweets when like 50% of them are the same, right? Ideally, there's a way that I can set up the query such that it's fetching unique tweets, right? Like that'd be better. And then lastly, right, like this could be expanded and generalized to other sports potentially. Although the advantage of the NFL in a sense is the lack of data, right? So I'm not necessarily going to other sports right away. But so with that, thank you very much. You can find me at hendricksoftware.com, and I'm happy to take any questions you might have. Thank you.
Hey, thanks for the talk. How did you distinguish player names from just normal words?
What do you mean? In what sense?
When you got the tweets, how did you distinguish the play names from words like a very common surname, etc.?
So I basically took the set of tweets, did the pre-processing steps I talked about, and then just dumped it into the IBM Cloud Sentiment API. So I myself didn't do any recognition of that. It's under the hood using, I believe, the BERT language model. But yeah, I didn't do too much in that specific area. Yeah. And actually, on that point, the previous presentation was talking about ChatGPT. I think GPT and LLM type models could be a much better replacement, honestly, than the IBM Cloud API. And that's definitely another area I'm probably going to be looking in pretty soon. Yeah. Over there.
Thanks for your presentation. Depending on who you talk to, Twitter has a lot of bots. How do you think that affects the wisdom of the crowd?
Well, I think to the point I was making about duplicate tweets and that, I think that's exactly that, right? I think it dilutes the value, right? If there's ways to query better to avoid those duplicates, I think that would help. And I think that's where it'd be very interesting, right, to do this kind of analysis in a kind of a closed group, right? You can imagine some kind of fantasy football group that you might have, or that I could create, for example, right? And then through that, right, you can control the number of bots and then get even cleaner data in a sense. But it's definitely a concern. Yeah. In the back there, in the middle.
Yeah, really interesting. Thank you. I guess my question is, did you look at the results and maybe, stratify them by like player performance? You mentioned top 250, which, as you said, they score the most points. That makes sense in some regard. But part of me wonders if actually maybe the opportunity is beyond that, right? Because like in a given week, Jamar Chase is going to score 16, 17 points. There's some variation. But, when the games tip on a player who has a really good week or a really bad week, outside of that, to me that feels like that's where the opportunity is. So I was just curious if you had broken it down that way any.
Not yet. I think that's a great idea to get further, right? Especially because there's so much. I think what you're getting at is the players that might be below that 250 could have like a ridiculously good game, and there's a lot of value there, right? That's where I'd like to get to be able to project that, right? And I think the first step to get there, though, is the injury piece and making that really strong, because that's going to be the telltale sign that that's going to be possible, right? But yeah, so far, no. Actually, the only stratification I've done is my little appendix slide is just positional, right? Which just shows that quarterbacks are the easiest to predict, which I don't think is a surprise to anyone. Here. Let's go back.
It wasn't clear to me what sentiment is represented as. Like, what kind of values is IBM delivering back to you?
Sure, yeah, it's a number between -1 and 1, right? So 0 meaning neutral, 1 meaning super positive, -1 being super negative. And so essentially, the typical values I would see is somewhere between 0.7 and -0.7.
First off, I really enjoyed the presentation. As a fantasy football nerd, I'm excited to use some of this data next year to hopefully win some leagues. Going off of what you're talking about with the top 250 from the previous week, I'm curious, why did you decide to use data from the previous week instead of maybe a larger sample size like last 4 weeks, or average of the last 4 weeks, or projections for that upcoming week?
Yeah, no, that's a great question. I think I might have, I don't know if I misspoke there. It was really just kind of the top 250 for like the current week of like what, let's say like NFL.com was projecting would be the top 250. So in that sense, I wasn't using the previous week. The reality is though, that top 250 is actually fairly stable, right? So there's not much movement in and out of that. So I don't know, like what I'm getting at is I don't know if it would have made a difference. And to some extent, there's really only so many players that are scoring, right? Even though there's, 52 players per team, 32 teams, that sounds like there's a lot of players, right? But half of those are on the defense, and they're represented by one kind of fantasy entity per team, right? And then a lot of the offensive, there's a whole special teams group that like doesn't really score many fantasy points at all, except for the kicker. And then you have, the skill positions is really where all the fantasy points are coming from. And so by 250 maybe sounds like a small number, but the total set of players that even score any points is only like 300, 400, maybe 500 at most in a given week. So it's really actually capturing the majority of scoring players. Yeah. One more question, okay. Right there.
So in your analysis, as you were looking through it, did you notice maybe any teams that were skewed to be overly positive or overly negative based off of their fan bases just being really angry or like really excited?
It's a good question. I didn't see any particular like leaning positive or negative, but I definitely saw like volume differences where some of the like more popular or famous teams definitely had way more tweet volume, right? It was actually just most pronounced though on a player basis, right? And it was interesting too, maybe the last bit to mention is, I mentioned I searched by player name, right? For the defenses, that meant searching by the defense's name, which is really the team name. And so that really kind of gave me a sense of like the volume per team. Obviously, a downside there is that wasn't necessarily just encoding the defense, but that's a separate point that I didn't talk about too much today. But, yeah. I think I'm at time, so thank you everyone. And I'll be outside if you have any more questions.